The story we were told is that we stopped going to the moon because of budgets and politics, but what if the truth is far more unsettling? What if NASA's new Artemis program accidentally uncovered the real reason we never went back? It wasn't a conspiracy hidden in the shadows. It was a set of brutal physics problems hiding in plain sight, problems that reveal the moon is a far more dangerous and hostile world than we were ever led to believe. Let's explore this together.
Heat shield failure.
What if the single most critical piece of equipment for bringing astronauts home is flawed? That's the terrifying question NASA faced after Artemis thirst. When the Orion capsule blazed through Earth's atmosphere in December 2022, its heat shield began to break apart in ways no one predicted. Chunks of the protective material, called AVCoat, were torn away, leaving unexpected gouges. According to Orion program manager Howard Hugh, the investigation that followed was taken with extreme seriousness, driven by crew safety. It took a team of experts nearly 2 years to solve the mystery. They discovered that Orion's unique skip guidance re-entry, where it dips into the atmosphere twice, allowed heat to build up inside the shield. This created gas pressure that the material couldn't vent, causing it to crack and shed charred pieces. NASA's models, built on decades of data, failed to see this coming. The failure exposed a critical knowledge gap in our understanding of hypersonic re-entry from lunar velocities. Such a flaw on a crewed mission would be catastrophic, leaving no margin for error. This single failure forced the agency to delay the first crewed mission, Artemis, seconds into 2026, proving that after 50 years, the simple act of coming home from the moon at 25,000 miles per hour is still a life-or-death physics problem we haven't fully solved.
Radiation rivers.
Imagine flying through invisible rivers of poison. During its journey, Artemis confirmed a threat that is far more insidious than heat-deep space radiation. We are currently at the peak of solar cycle 25, a period of intense solar activity predicted to climax in July 2025. Solar scientist Lika Guhathakurta has emphasized that preparing for this space weather is critical for the Artemis program. The sensors aboard the uncrewed Orion capsule revealed something chilling. Simply by changing the spacecraft's orientation, by rotating the vehicle, the radiation dose inside dropped by as much as half. Let that sink in. The difference between a safe mission and one that could expose astronauts to cancer-causing levels of radiation could come down to which way the ship is pointing during a solar storm. This isn't just about having thick hulls, it's about navigating unseen cosmic currents at exactly the right angle. Artemis carried phantom torsos, named Zohar and Helga, packed with sensors to measure organ-specific radiation doses, confirming the danger is not uniform. The data showed that without proper shielding and orientation, a single large solar flare could deliver a mission-ending dose of radiation in just a few hours. During the Apollo era, missions were short, but for the long-duration stays planned for Artemis, this radiation danger is a constant, potentially lethal variable that makes every moment outside Earth's magnetic field a high-stakes gamble.
Deadly dust.
The biggest threat on the moon might be the ground beneath our feet. Apollo 17 astronaut and geologist Harrison Schmitt was the first to experience it directly in 1972, calling it lunar hay fever. He and other Apollo astronauts suffered from sneezing, watery eyes, and sore throats after dust got into the lander. But this is no simple allergen. Lunar dust is made of microscopic shards of glass and minerals, formed by billions of years of meteorite impacts. With no wind or water to smooth them down, the particles are as sharp as broken glass. Worse, the sun's radiation gives them an electrostatic charge, so they cling to everything: spacesuits, visors, seals, and, most terrifyingly, human lungs. Modern studies confirm the danger. These tiny daggers can tear through lung tissue, causing long-term damage. Schmitt reported that the smell of the dust was like spent gunpowder, a sign of its reactive nature. The particles are so abrasive, they wore through layers of astronauts' boots and contaminated the seals of their sample containers. It's an engineering nightmare that Apollo only gave us a glimpse of. The dust grinds away at seals and joints, blocks instruments, and covers solar panels. We're not just going back to a dusty rock, we're landing on a world covered in microscopic glass that actively tries to invade and destroy everything we bring with us.
Gravity traps.
Imagine flying a spacecraft that is constantly being pulled off course by invisible mountains. This was the reality for Apollo mission planners, who watched in confusion as their carefully calculated orbits would suddenly decay. The cause was a phenomenon they didn't fully understand until much later. Mascons, or mass concentrations, buried beneath the lunar surface. It wasn't until 2012 that a mission led by principal investigator Dr. Maria Zuber finally mapped these invisible hazards. The mission, called GRAIL, used 2 spacecraft flying in precise formation to create a detailed map of the moon's gravity. The result was, honestly, just stunning. The map revealed a lumpy, uneven gravity field, with massive concentrations of dense material lurking under the large lunar basins. These mascons create powerful gravity wells, invisible traps that can pull an orbiting spacecraft down by hundreds of feet per second. This was first noticed by JPL's Paul Muller and William Sjogren in 1968, but it took decades to get the full picture. For Artemis missions targeting the lunar South Pole, a region of extreme craters and shadows, these anomalies make precise landings incredibly difficult. Navigating to a pinpoint landing spot is like trying to sail through a sea with unseen whirlpools. Apollo crews had to constantly make corrections. For Artemis, which aims for pinpoint landings in treacherous polar regions, these gravity traps present a constant and unpredictable danger.
The moon rings.
What happens when you hit the moon? Well, it rings like a bell. This isn't just a metaphor, it's a deeply unsettling discovery made on November 20, 1969. After the Apollo 12 crew left the surface, NASA deliberately crashed their lunar module's ascent stage back into the moon. The sensitive seismometers the astronauts had left behind picked up the impact. Scientists expected a tremor that would last a few minutes like an earthquake. Instead, the moon vibrated for over an hour. University of Texas geophysicist Yoshio Nakamura, who spent years analyzing the Apollo seismic data, noted how profoundly different this was from anything seen on Earth. They repeated the experiment on later missions with even larger impacts, and the results were the same. The moon would ring, sometimes for up to 4 hours. Unlike Earth, where water and magma dampen seismic waves, the moon's interior is bone-dry, rigid, and fractured. This allows vibrations to travel through it almost completely unobstructed. A single meteorite strike can cause the entire body to resonate, revealing secrets about its ancient, violent past. The entire celestial body resonates from a single impact. This discovery paints a picture of a geologically dead but strangely resonant world, one whose fundamental structure is completely alien to our own, and holds secrets about its violent formation that we are only just beginning to comprehend.
Forgotten data.
Humanity placed ears on another world, and then we chose to go deaf. For 8 years, from 1969 to 1977, the seismic stations left by Apollo astronauts sent back a continuous stream of data on moonquakes and meteorite impacts. Then, on September 30th, 1977, NASA sent the command to shut them all down. The official reasons were dwindling power from the generators and budget cuts to pay for the upcoming space shuttle program. We willingly abandoned our only active scientific outpost on another world. But, it gets worse. In the 1980s, during a shortage of magnetic tapes, NASA erased and reused the original, high-quality television recordings of the Apollo 11 moonwalk. The raw footage of one of humanity's greatest achievements was wiped to save a few dollars. According to Apollo-era engineer Dick Nafzger, who led the painstaking search for the lost tapes years later, it wasn't malicious. It simply slipped through the cracks. This loss is incalculable, as the original tapes contain far more detail than the broadcast versions we all know. These actions represent a pattern of neglect. We not only stopped going to the moon, but we also stopped listening to it, and even erased parts of our own memory of being there.
Soviet failures.
While America celebrated its Apollo victories, its Cold War rival suffered a series of catastrophic failures in total secrecy. The Soviet Union was just as determined to reach the moon, and their hopes rested on a monstrous rocket called the N-1. Overseen by the legendary chief designer Sergei Korolev, the N-1 was the Soviet counterpart to the Saturn V. But, unlike the flawless record of the Saturn V, the N-1 was a disaster. All 4 of its test launches between 1969 and 1972 ended in failure. The first exploded just over a minute after liftoff. The second, just seconds after clearing the tower, fell back onto the launch pad in what became the largest non-nuclear explosion in history. destroying the entire launch complex. Korolev's sudden death in 1966 left the program without its central visionary, leading to internal conflicts and design compromises. The rocket's first stage, with its complex cluster of 30 engines, was a key point of failure that could never be properly ground-tested. The final 2 rockets also failed before ever reaching orbit. These repeated, devastating explosions effectively ended the Soviet dream of landing a cosmonaut on the moon. While the world saw a one-sided race, the truth was that the physics of building a moon rocket was so brutally difficult that it completely defeated one of the world's 2 superpowers.
The long gap.
Why did 50 years pass without a single human venturing beyond low Earth orbit? After Apollo 17 in 1972, the final 3 moon missions, Apollo 18, 19, and 20, were cancelled. Officially, the reasons were budget cuts and a shift in focus to the space shuttle. Decades later, in 2004, a return seemed imminent with President George W. Bush's Constellation program, which aimed to put astronauts back on the moon by 2020. But in 2010, President Barack Obama canceled the program entirely. A review had declared it over budget and behind schedule. The Augustine Commission, which reviewed the program, found it was on an unsustainable trajectory. Billions of dollars were spent, but not a single piece of lunar hardware ever flew. This history of starting and stopping reveals a deeper truth. Bureaucracy and budgets are convenient explanations, but they don't capture the sheer difficulty of the task. The long hiatus also led to a loss of irreplaceable manufacturing capabilities and institutional knowledge that had to be painstakingly rebuilt for Artemis. Each time we have tried to restart our journey to the moon, we have run headfirst into the same wall, the immense cost and complexity of overcoming the physics of deep space travel.
Artemis struggles.
Artemis is not picking up where Apollo left off. It is starting over from scratch, and the struggle is immense. As NASA Administrator Bill Nelson has acknowledged, the challenges are staggering. NASA's total campaign costs are projected to reach $93 billion by 2025, with each of the first 4 launches costing an estimated $4.2 billion. The program has been a battle against technical delays and soaring budgets. The Space Launch System rocket took years longer than planned to develop. The Orion capsule's heat shield problem required a 2-year investigation. The next-generation spacesuits, being built by Axiom Space, have faced delays and are over budget, struggling to meet NASA's requirements for mass and resource consumption. And SpaceX's human landing system, the Lunar Starship, has yet to even reach orbit for a test flight. The U.S. Government Accountability Office has repeatedly warned that the program's schedule is unrealistic, pointing to the immense complexity of integrating brand new systems from multiple contractors. This isn't just a NASA project, it's a massive orchestration of different companies, each with its own hurdles. The Artemis program reveals a sobering reality. Even with 50 years of technological advancement, every single component required to safely land humans on the moon is pushing the very limits of our engineering capabilities.
Hostile environment.
The single greatest reason we haven't returned to the moon might be the moon itself. It's not a passive, dusty rock, it's an environment of violent extremes, fundamentally hostile to human life. As pulmonary physiologist Dr. Kim Prisk notes in his research, we still don't fully understand how dangerous its dust is to our bodies. The temperature swings are brutal, from 250 degrees Fahrenheit in the sun to minus 250 degrees in the shade. A 500-degree difference that can occur over just a few feet. With no atmosphere, there is no protection from radiation and micrometeorites. The electrostatically charged dust cuts like glass and invades every piece of equipment. The invisible gravity wells, or mascons, make stable orbits a constant challenge. This extreme thermal cycling can cause materials to become brittle and crack, a huge risk for long-term habitats. Even the very light and shadow create problems, with the low sun angle creating deep, dark shadows that can hide dangerous craters and rocks from landing spacecraft. What the new program is uncovering is not a conspiracy, but a set of harsh physical truths. The moon is an active, hostile environment that pushes back, and overcoming it is proving to be the hardest challenge we've ever faced. The evidence is clear. We didn't just stop going to the moon because we lost interest. We stopped because we discovered it was far more dangerous and difficult than we ever let on. The Artemis program's struggles with heat shields, radiation, and immense costs are not new failures. They are echoes of the same brutal challenges that nearly defeated Apollo. The greatest achievement wasn't just getting there in 1969, it was surviving the trip. What do you think is the single biggest obstacle we still need to overcome? Let me know in the comments below. Don't forget to like, subscribe, and hit the bell icon so you don't miss the next chapter of our journey back to the moon. Thanks for watching Space Facts.